The bizarre interstellar visitor that's rewriting astronomy. Something unexpected just happened in our cosmic neighborhood. A visitor from beyond our solar system has arrived, and what scientists are discovering about it is forcing them to question everything they thought they knew about interstellar objects. This isn't just another space rock passing through. The data coming back is so unusual that researchers are struggling to explain what they're seeing. And the more they look, the stranger it gets. A cosmic outsider arrives. As of today, October 13th, 2025, humanity has documented only 3 confirmed objects that originated from another star system. The latest arrival, designated 3I/Atlas and discovered this past July, is proving to be the most perplexing yet. How do astronomers know it's truly from another star? The velocity tells the story. This object is traveling at speeds exceeding 130,000 miles per hour on a trajectory so steep that the sun's gravity cannot capture it. It's following what's called a hyperbolic orbit. It will swing through our solar system once and disappear forever into the void. The mathematics reveal something even more intriguing. This visitor likely originated from the thick disk region of our galaxy, an ancient zone that could make this object older than our entire 4.6-billion-year-old solar system. We're essentially looking at a messenger from time and place we can barely comprehend, breaking the rules from day one. Here's where things get weird. Most frozen bodies from space don't become active until they get close to the sun's warmth. But this object started releasing gas and dust back in May, while still beyond Jupiter's orbit, roughly 6 astronomical units from the sun. That's like turning on an air conditioner in winter. It shouldn't happen, yet it did. Initial measurements suggested the core could be anywhere from 3.5 to 7 miles across, potentially making it the largest interstellar object we've detected. But size is just the beginning of the mystery. A chemistry that defies explanation. When the James Webb Space Telescope analyzed the object composition in early August, researchers discovered something unprecedented. The gaseous atmosphere contained approximately 8 times more carbon dioxide than water vapor. Think about that ratio for a moment. In virtually every comet from our own solar system, water ice is the dominant material. Carbon dioxide is typically minor. Here, that relationship is completely inverted, an 8-to-1 ratio of CO2 to water. Scientists have found only one comparable case in our entire catalog of solar system comets, and even that wasn't as extreme. This chemical signature strongly indicates that this visitor formed in conditions radically different from our own solar system. Perhaps it formed in a region so cold that CO2 could freeze solid, while water remained gaseous. Or maybe its surface developed a thick insulating crust over billions of years, trapping water ice deep inside, while allowing only carbon dioxide to escape through cracks. But here's the twist that makes this even more intriguing. The isotope ratios detected in the gases are remarkably similar to what we find here on Earth. The carbon fingerprint matches our own planetary composition. This creates a paradox. The chemistry is exotic and alien, yet its fundamental atomic signature suggests it formed around a star not too different from our Sun. The impossible teardrop. When Hubble captured high-resolution images in late July, scientists saw something that contradicted every textbook description of cometary behavior. Instead of the classic tail streaming away from the sun, this object is wrapped in an asymmetric, teardrop-shaped cloud of dust. The dominant feature is a massive plume of material pointing toward the sun, essentially the opposite of what should happen. One researcher noted that the object was actively shedding dust even when it was nearly 4 times farther from the sun than Earth, another complete violation of expected behavior. The leading explanation? The object is approaching an extremely steep angle, and we're witnessing a massive stream of dust being ejected from the sunward side. It's like seeing car headlights from the front rather than taillights from behind. This peculiar behavior has led some researchers to speculate that this visitor might be approaching a star for the first time in millions of years. For eons, it drifted through the frozen darkness of interstellar space. Now, awakening to stellar heat, it's behaving in ways that don't match our models. An unprecedented opportunity. Here's where the story takes an exciting turn. While the object won't come particularly close to Earth, fate provided an extraordinary opportunity. The trajectory brought it much closer to Mars. On October 3rd of this year, the visitor passed within approximately 18 million miles of the red planet. Multiple spacecraft orbiting Mars attempted to observe an interstellar object from another vantage point in our solar system, something that's never been done before. The European Space Agency mobilized 2 Mars orbiters using cameras and spectrometers to capture not just images, but spectral data that could reveal which gases are being released. NASA's Mars orbiters and even China's Tianwen joined what became an unprecedented interplanetary observing campaign. We're witnessing international cooperation on a scale rarely seen, all focused on understanding this cosmic visitor before it disappears forever. The wild speculation. Whenever an interstellar object arrives, it inevitably attracts speculation about artificial origins. Our first confirmed visitor in 2017 sparked intense debate when some suggested it might be an alien probe. Now, with this latest arrival showing its own anomalies, the forward-facing glow, the unusual chemistry, the premature activity, similar questions have resurfaced. Could this be something other than a natural object? The evidence points firmly toward natural phenomena. The dust plume and carbon dioxide dominance can all be explained through known physics and chemistry. The orbit follows gravitational laws precisely, with no unexplained deviations that would suggest propulsion systems. Still, the excitement generated some audacious proposals. One suggestion involved repurposing NASA's Juno spacecraft, currently orbiting Jupiter, to chase down the visitor using a gravity assist maneuver. While technically intriguing, such a mission would require fuel that Juno simply doesn't have. Looking ahead, a dedicated mission called the Comet Interceptor is being prepared specifically for scenarios like this. The spacecraft will launch to a parking position and wait. When a new interstellar visitor is detected, it can be dispatched for close-up observations using deployable probes. What happens next? Before 2017, interstellar objects were purely theoretical. Now, in just 8 years, we've detected 3. Each visitor carries information about its home system frozen in its composition and structure. They're essentially free samples from distant stars, delivered to our doorstep. As this visitor reaches its closest point to the Sun later this month, additional observations may reveal even more. Will water ice finally begin sublimating? Will the dust patterns change? Every data point helps refine our understanding. The larger implication is profound. We are no longer limited to studying only objects that orbit our sun. The universe is delivering samples from distant star systems, and we're developing the technology to study them effectively. Statistical models suggest these interstellar travelers pass through the inner solar system more frequently than we once thought. We simply lack the detection capabilities to spot them until recently. The next visitor could arrive next year, in a decade, or tomorrow. When it does, we'll be more prepared with better instruments, faster coordination, and perhaps even dedicated intercept missions ready to launch. The cosmic mystery deepens with every observation, and we're only beginning to understand what these interstellar messengers are telling us about our galaxy. If you want to stay updated on the latest discoveries about this visitor and future objects from beyond our solar system, subscribe now. We're living through a golden age of interstellar discovery, and the most shocking revelations may still be ahead. Don't miss what comes next.